Good morning. My name is Maureen Baer, and I work with Ben Kickert, who some of you may know. Ben will be joining us for the live Q&A. Our third colleague is Kenneth Blake, who leads our editorial work. Let me give you some context about our scale. We're an organization of just the three of us. We each work around 20 hours a week. My presentation today is a counterpoint to Ben's. While he's given you lots of really good in-depth Wolfram coding and information, I'm going to step back and give a 10-year retrospective on how we've been using Wolfram to drive social impact for our organization. The three of us work together on two initiatives. Starting Up Good, which focuses on providing information to guide social entrepreneurs and impact investors, and SDGCounting, which focuses on keeping track of how the United Nations and others are measuring and tracking results on the Sustainable Development Goals. Here's a statistic to sort of set the stage. We, mostly Ben, have created over 1,500 notebooks in 10 years. That includes versioning, proof of concepts, and fully deployed projects to create the foundations for and to drive our work. The goal for this presentation is, first, to try to take our Wolfram work and line it up against our organizational goals in 2-year eras. Then I'll make some assessments on the next 2 years and what we see Wolfram's role being based on conversations we've had as our 3-person team. And finally, I'll finish by giving our wish list for Wolfram so that we can all continue to use it as a backbone for our work for the next 5 years. That's until the end of the timeline for the current Sustainable Development Goals. Our story starts in 2015, the first year of the United Nations Sustainable Development Goals. These 17 goals were designed to focus global attention on building a more equitable world by addressing issues like climate change, poverty, hunger, and access to healthcare and education. In 2015, I was a Wolfram hobbyist. I was especially fascinated by what Mathematica could do with text analytics. I'm not a programmer by training, but I loved exploring what was possible. I do want to give a shout out to William Turkle for his formative 2015 notebook, Digital Research Methods with Mathematica, which really introduced me to the powers of textual analysis within Mathematica. In 2015, the first year of the Sustainable Development Goals, the 17 headline goals were publicized with 169 sub-targets, but the underlying tracking and indicator frameworks were not yet well developed. The UN and its member countries, each with different statistical methods, needed several years to organize a cohesive system for data collection. The scope of the SDGs was aspirational, but pinning down the data was immensely difficult. Most of our focus in 2015 was on getting the Starting Up Good initiative off the ground. There was lots of interest in impact investing and in social enterprise startups, so we wrote lots of articles and attended many conferences. Ben had not yet joined us as a full team member, so not much Wolfram for our work was happening then. In the next 2 years, while the world got organized on metrics for the SDGs, we decided to use Wolfram in other creative ways, especially for social media analysis. Ben joined us during this time. And Wolfram at that time had very strong service connections with platforms like Twitter, Facebook, LinkedIn, and Instagram, which made it possible for us to use it to plan, analyze, and schedule social media campaigns effectively. Unfortunately, most of those platforms have cut off access to lots of their data. So we can't continue to do things as we did in 2016 and 2017. We also began exploring impact investing databases like Crunchbase to better understand the investing ecosystem for impact investing, and designed analytical tools that made the complex data more accessible. For philanthropic tools, there was lots of work done on analyzing 990s and other public grant data. This was the period where Ben and Wolfram developed truly strong skills in taking ill-formed data and transforming it into clean, usable SQL-type data sets. By 2018 and 2019, things around SDG counting had improved. The SDG reporting mechanisms had matured significantly. This was in many ways the heyday of global goals work. Indicators were in place and hierarchical mechanisms for getting data from the field to the top of the UN began to work so that reports were both comprehensive and as much as possible complete. The data pipelines were better, and this allowed us to dive deeper into SDG analysis. We started building our own custom data structures using Wolfram's entity framework, which was introduced to us around that time. Ben pioneered new ways to handle large-scale database integration, bringing together government data, corporate reporting, and open data sets, and making them into coherent structures that we could use for our analysis and articles. In 2020, COVID happened, and we began to pay a lot more attention in 2020 and 21 to what was going on with COVID, and later to hands-on, on-the-ground projects. We began doing more reports and paid attention to what corporations were doing because of COVID. We also started to keep track of certain COVID statistics, especially as they related to the Sustainable Development Goals. The big project for this time was actually an on-the-ground project where we paid attention to providing women of color in the Atlanta region with consulting support and grants that would allow them to do better work with their social enterprises. Most of our vetting, selection, and work with the candidates used Wolfram Tech to pull together candidate profiles, lists, and work products for the candidates. Another project that we did during this time was what I called VR learning rooms. These were using Google Chrome or Facebook Oculus 3D rooms where we could bring together the results of web image searches, say searching on Sustainable Development Goal 1, no poverty, and then pull in 20 to 30 images. We'd organize the images into an internal 3D space so that one could walk through and visually see everything that was going on the topic. In 2022, AI using LLMs became central to everything we did. We started integrating AI before Wolfram had its own built-in LLM functions. We connected directly to APIs from OpenAI and others, continuing to use Wolfram as the glue. We'd send prompts to AI models, bring the results back into Wolfram, and then slice, dice, format, and analyze the output there. This division of labor worked beautifully. AI handled content generation and creative interpretation. Wolfram handled data processing, structuring, verification, and output formatting. To make the workflow easier, especially for me as a non-programmer, it was during this period that Ben developed what we call super functions. These are robust code snippets for common tasks assembled into a shared toolkit. They allowed me to build complex processes ad hoc without getting bogged down in coding details. I could focus on what needed to happen from my point of view, and the toolkit gave me the pieces to make it happen. This toolkit has become essential to how we work. It's grown and evolved, and it's now a core part of our infrastructure through many, many versions, additions, and reformatting. Now we come to the current time. The coming in of the Trump administration has had huge impacts on our mission. Many of the things we pay attention to have been defunded. Many databases from the United States government that we have used have been taken offline. Whole organizations we relied on for data have disappeared. Our content and mission have been challenged, causing us to have to re-platform. ESG and DEI, nobody says those acronyms anymore. Impact investing has been challenged by red state pension funds. The SDGs themselves have been denounced by the U.S. administration. Yes, there is a silver lining. During COVID, counting improved because some things were done quickly that would have taken much longer. They were able to be truncated around the UN's bureaucracy. Better counting mechanisms were put into place by countries because they couldn't count in traditional ways and they needed more comprehensive counting to be able to know what was happening with their own healthcare systems, etc. We were able to leverage some of these things to compensate for and mitigate some of the bad things that have happened in the past year. Now let's look forward. How are we going to use Wolfram and integrate it with AI and other tools over the next few years? At this point, Wolfram, LLMs, and I'm assuming agents soon, will be implemented within the Wolfram framework. We'll probably still keep our own APIs directly into OpenAI, Anthropic, and Google, because in some cases it serves our purposes better than going through the Wolfram language for LLMs. We're planning to move from static pages and articles to interactive apps. And that will definitely mean using codecs plus whatever Wolfram's equivalent is going to be. We think that in the next 5 years, we'll actually be moving closer to our original vision, where the measurement of what's happening is much closer to where it's happening, whether that be through satellites, other kinds of mapping, or counting from people on their iPhones or other appliances. We see a good future for that. We spend a lot of time talking about where Wolfram fits into our overall ecosystem as we find ourselves migrating more and more toward the AI ecosystems. ChatGPT, the Microsoft ecosystem, or Anthropic, or Google. Still, we find ourselves returning to Wolfram often. I see that there are 4 key reasons for this. First of all, the Wolfram language is a language that both Ben and I can communicate in. He communicates proficiently, and I use basic Pidgin Wolfram. It feels comfortable to us since we've developed our tools together over many years. We hope that we can keep that going on. Secondly, we still don't trust that what we're getting out of AI is always going to be factual. With Wolfram, we can build various ways to check things out by having different kinds of queries to check citations and things like that. Third, the data still needs to be smooth because it's coming from so many different places. The toolbox is good at this point because it allows us to take data that's jagged or uneven or unmatched in different formats and smooth it into formats that can be read across Wolfram at least, and then to export it in various ways. And still, for large batches, Wolfram continues to be the best place for us when we're doing any kind of batch processing on large amounts of data. None of the AI ecosystems currently have big enough ability to handle a whole lot of data at once. They're getting bigger and better, but they're not there yet. We find ourselves going back to Wolfram for this and for anything that requires batch processing. But we continue to worry about whether Wolfram will keep up with the quick changing technical ecosystem based on AI. There are 4 key things that we think Wolfram needs to do to keep us within the ecosystem as much as we want to stay. The first is to allow us to smoothly incorporate our own APIs with Wolfram's so that we can use things that Wolfram does best with many, many external APIs without having to reformat everything for Wolfram. Second, and this is a long-term wish from us, the content in Wolfram is not as robust as we would love it to be. I think we need to pay more attention to keep the content up to date, to fill in the gaps in content ontologies. For every new entity you add, things like fictional animals, for example, I think you should spend at least twice as much time on keeping the foundational entity types clean and current. The third thing is better standards compliance. A lot has been invested by Wolfram in trying to standardize and get with where the rest of the world is. The idiosyncrasies make Wolfram both better and more challenging than most software. But there are still non-standard things that are just a little bit off. And it would be a lot easier for us if we did not have to do workarounds for those kinds of things. And finally, on our wish list, it's probably not finally, but for now, we wish that there were easier ways to have interfaces within Wolfram. The Wolfram notebook interface is not as good as visual interfaces. It's very linear. There's no layout other than through a fairly complex set of coding. And we still don't have ways to manipulate things on touch screens and other appliances, though there have been lots of experiments there. I just finished watching Stephen's presentation for this year. And I want to say that the bottom line is we love Wolfram 10 years in. It's been really, really useful for us. We see it as a bridge technology for the next 2 or 3 years for sure. But we think that Wolfram needs to keep up on some of the bread and butter issues we've mentioned as you continue to innovate so that it can remain the core of our work for the next 5 years. Thank you. I'm happy to answer questions now.
There is one that came in. The question from Jason is, can you give an example where standards compliance is not meeting your expectations?
Yeah. I think the one that comes to mind, there are two examples. Dark mode is something that has just appeared in Wolfram. It's been standard in pretty much other software for a long time. And autosave still is not working in Wolfram, and it would be great if it did. Do you have any, Ben? I think you come from a different perspective as a real coder.
No, not off the top of my head. There is also another question related to your ending. A couple actually. Can you elaborate on some entity types you feel would be most important to update beyond the old data?
Yes. So where we use the entity types, or I use the entity types most, are in demographics, things like countries, cities. Whereas a lot of the entity categories, the proteins and biomolecules and things like that, are state of the art. When it comes to demographics and the bread and butter things that we like, statistics for demographics, things like that, we would like to be able to rely on Wolfram as our place to test out what we're getting from other places. In other words, to benchmark against Wolfram. But sometimes, not in all cases, you can't find the sources in Wolfram for those things, and it's not the most up-to-date data. Now, in other cases, it is, and in some cases, the lags are because the data providers are not up to date. But this is a wish list, and I particularly would love it if Wolfram was my go-to for statistical data on things like countries and health and cities, and those kinds of things.
Yeah, I would agree with that. I think knowing that a lot of our work does center around UN data, and we have entire presentations about the frustrations of working with the UN. So I think there is there's definitely an understanding that having the most accurate UN data is the exercise in and of itself. But being able to incorporate that, knowing quickly and easily that the tuberculosis data, for instance, is the most up to date. We've got another question from Shadi. I wonder if we've used Wolfram for creating visualizations of all the data.
Ben, that's more for you.
Yeah.
Yes is the answer.
But yeah, yes is the answer. We actually had a team meeting recently, talking about how we want to utilize Wolfram more. We've used very simple things like word clouds, lots within the graphing and charts, but the geo data, some of the work that Jose has been doing is really exciting to us, and that's a piece that we would definitely like to include. And I think that it's also part of the ebbs and flows of our own interest. There are months, quarters, years where we're more focused on the specifics of the data, and then visualization is more important. And then at other times, we're more interested in the data flow, and the processes behind that. I know that a lot of the network graph pieces are something that we could probably incorporate. But that's something that is kind of listed as I need to look into that, but we haven't done it yet. Next question from Andrew: for your pipeline data processing flows, do you carry forward meta information about the content and software versions that generated your results? It's okay, I'll go ahead and take that one. And I would say that actually the best answer for this is that this is one of the main reasons that we use Wolfram. Using the notebook paradigm allows us to include in the code that we're doing the computations the notes about our findings, as well as embedding the metadata, showing the process that was there. This is one of the things that, from a ability to share that level of data from the computation through the results, is probably why we've stuck with Wolfram over anything else that we've tried, because it does allow for that documentation, and from a software versions, we also have that embedded. I think Maureen mentioned earlier in the presentation about having 1,500 or 1,600 different notebooks, and even being able to recap what we've been working on. We're often going back to the data within those notebooks to find the results. From John, we have: I agree. I usually use HTTP request on the OpenAI API myself rather than LLM functions. Can you elaborate on other model provider APIs that have features you missed from the built-ins? Um, we've seen over the last 3 years very rapid development within LLMs as a whole, and also within Wolfram's utilization of those. The two things that keep me personally into writing my own API calls and using the HTTP request is we are often watching very eagerly all of the presentations that are coming from OpenAI and from Gemini. And when a new feature is being launched for developers, we want to be able to include that immediately to see if it can fit into our workflows. And so that desire to be cutting edge when things like computer vision and multimodal were integrated into the OpenAI API, we wanted to play with that afternoon, and so that's probably one of the biggest reasons. On the other hand, I think that for daily changes, using the LLM synthesize certainly is an effective way to take advantage of the full team at Wolfram that are working on that. In some ways, if it's not broke, we're not going to fix it in terms of our own personal data flows. So that's there. The other piece is that from a understanding what's going on behind the hood, LLMs are always going to be black box in some way. And there's a desire to make sure that we demystify as many things as we can. So when I'm looking at something like LLM synthesize, I want to know exactly what's going on, and I know that can be pulled out, but that's kind of led to our persistence with our own handwritten APIs. But as things continue to develop, I have no doubt that the Wolfram team is going to be able to develop much quicker than we can as a small team. Maureen, anything to add, though?
The one thing I'll add is that the reason that I at least don't use the Wolfram language, LLM synthesize, and things like that is that we started before it existed. So we have sort of legacy processes where Ben has built something that goes right to the API, and I at least haven't adjusted to use the Wolfram language for that because I'm a shortest distance between 2 points kind of person.
Final question, because I think we've reached our 30 minutes, from Matt. Does Wolfram language have the capability of taking in a set of axioms as assumptions, applying it recursively to hypergraph, and then querying the resulting structure? We're out of time. We're going to have to rely on Wolfram to answer that one. So thank you for that, but that is beyond beyond the scope of our talk, and probably the scope of my ability.
Take care.
Thanks to everyone. Cheers.